Welcome to GR Hub Mathematics and Statistics lessons. Today we shall be considering Surds part 6, where in particular we shall be looking at equality of surds. So when are two surds said to be equal? That is one consideration in our class. The second consideration is where do we apply this knowledge of equality of surds directly to? So we shall be answering these two questions in this lesson and following it up with examples showing you how equality of surds can actually be applied. So let's start straight away with the first one. Now, two surds, say this and this, are said to be equal if they satisfy the following condition. So if two surds in this manner are equal, then the first condition is that A must be equal to B. The second condition is that root B must be equal to root D. And that implies that if root B is equal to root D, then it implies that B must be equal to D. Okay? So take note, when are two surds said to be equal? Two surds are said to be equal if this is equal to this and this is equal to this. Okay? If their respective terms are equal to one another. Now, where do we apply this knowledge of equality of surds? We apply this knowledge on equality of surds when we try to determine the square root of what we call surdic numbers. So when trying to determine the square root of surdic numbers, the idea of equality of surds can play a very vital role. So to answer the question, where do we apply the knowledge of equality of surds? It is in trying to determine the square root of surdic numbers. So surdic numbers are numbers that have a surd component in them. Now let us consider this example. The example here comprises two problems whose square root we seek. So we want to get the square root of this number, which is a surdic number because it has a surdic component. We also want to get the square root of this number since it has a surdic component. So how do we go from here? We are going to consider the first one. For the first problem, since we want to obtain the square root of 3 plus 2 root 2, which is a surdic number, the first thing we do is to assume what kind of square root it will give. If the number whose square root you seek has a sum or an addition sign, the square root must have an addition sign. So the first thing you do in trying to obtain the square root is to assume how or what kind of square root it will give you. So we usually would assume that the square root of such a number would be of this form. Now, that being said, the next thing you do in the solution process is to take the square of both sides. When you square both sides, you end up having this. So that gives you 3 plus 2 root 2 equals a plus 2 root ab plus b. So that is when you take the square of both sides. Now, if you take like terms, constants or terms without the surd come together to give you a plus b, and terms with the surd takes a term on their own. Now, when you compare the left-hand side, this, to the right-hand side, you will notice that 3 can be compared with a plus b. So 3 is equal to a plus b. We call that equation 1. 2 root 2 can be compared with 2 root ab, and that would, when simplified, gives us what we are going to call equation 2. So 2 root 2 is equal to 2 root ab. 2 root 2 and 2 root ab have something in common. The fact that they both have 2, which can divide both sides, and that gives us root 2 equals root ab. Now, when you take the square of this, if you square both sides of the last equation, you end up having an equation 2, which we are going to call 2 equals ab. Now, from equation 1 here, you will notice we can make a the subject of formula. When that is done, it gives us 3 minus b, and that brings about this. Okay, so substituting for 3 minus b, a equals 3 minus b in equation 2 here gives you 2 equals b into bracket 3 minus b. Now, when you expand this, it gives you 2 equals 3 times b is 3b, then b times b is minus b squared in this case. So if you simplify by rearranging this equation, you end up having b squared minus 3b plus 2. When b squared is taken to this other side, 3b is also taken to this side with 2 remaining there, This gives the right hand side gives you 0, the left hand side gives you b squared minus 3b plus 2. Now, to solve that problem, we are going to be taking note of the fact that the quadratic equation, the general quadratic equation, takes the form ax squared plus bx plus c, and using the quadratic formula, the solution can be gotten as this: x equals minus b plus or minus square root of b squared minus 4ac all over 2a, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So now, using that idea to solve this equation, b squared minus 3b plus 2 equals 0, gives us b equals minus, in bracket, minus 3. Now take note, the coefficient of b here in this case is minus 3. So minus times minus 3 will give you plus 3. Plus or minus square root of what your b is, which is minus 3. That's the coefficient of b is minus 3 all squared minus 4 times your a, which is the coefficient of b squared here, and it is 1. Multiplied by your c, the constant term, which is 2. That gives you 9 minus 8, and 9 minus 8 is 1, all over 2 times 1, which is 2. Bring it down here, this is also 2. So it ends up giving us 3 plus or minus square root of 1 all over 2, and the square root of 1 is 1. So that gives us 3 over 2 plus 1 over 2, or 3 over 2 minus 1 over 2. And simplifying this, 3 over 2 is 1 1/2. 1 1/2 minus half will give you 2. Or 3 over 2 minus half is 1 1/2. Okay, sorry, this was 3 over 2, which is 1 1/2 plus half, giving you 2. That is 4 over 2, okay? And 4 over 2 is 2. So in the second case, 3 over 2 minus half is 1 1/2 minus half, which is 1, okay? Now, so now that we've obtained the values of b to be 2 or 1, when b is 2, what would a be? We can now recall, you can recall quickly that your a was obtained, expressed as 3 minus b. So remembering that a was expressed as 3 minus b implies that you can actually get your a value by subtracting b from 3. So that would be 3 minus 2, giving you 1, when your b is 2. What about when your b is 1? When your b is 1, all you have to do is to subtract from 3 that value 1, and that will give you a equals 2. So when b is 2, a is 1. When b is 1, a is 2. Now, that brings us to the end of that particular problem, where we can now summarize by telling ourselves what the square root of 3 plus 2 root 2 is. It is either square root of 1 plus square root of 2, or square root of 2 plus square root of 1, as the case may be. Now, you can verify that your answer is correct by taking the square of either of these answers. It will surely give you this, and that tells you that your answer is correct. Now let's consider the second problem. For the second problem, you will notice that the square root of 7 minus 2 root 3 is sought, and that is equal to, we are assuming in this case that the square root will give us square root of a minus root b. Now, if you take the squares of both sides, it will give you this, which simplifies to a plus b minus 2 root ab, okay? Now, again, just like we did in the former example, if you compare both sides, you will notice that 7 can be compared with a plus b, which gives equation 1, and minus 2 root 3 can be compared with minus 2 root ab, which simplifies to equation 2, giving us 3 equals ab as our equation 2. Now from equation 1, again, we can make a the subject of formula, and that will give us 7 minus b, okay? So that brings us to this point. So a equals 7 minus b. Now when you substitute for a equals 7 minus b in equation 2, that will give you 3 equals 7 minus b times b, which reduces to 7 times b equals 7b, and b times b gives you b squared. So 3 equals 7b minus b squared reduces to this when rearranged. Now if you use the quadratic formula again, which I would want you to check thoroughly, you will end up having that minus, in bracket, minus 7 plus or minus square root of minus 7 all squared minus 4 times 1 times 3 reduces to the final answer we got here as this for B, or this for B. Okay, now I want you to check that routine. It is very simple. Remember, by the quadratic formula, the A term is the coefficient of the B square. The B term is the coefficient of B, yeah? And your constant is 3. So if you put that into the quadratic formula, you end up having minus in bracket minus 7 plus or minus square root of minus 7 all squared minus 4 times 1 times 3 all over 2. All over 2 times 1. And that gives you 49 minus 12 all in the root, under the root, plus or minus 7 over 2. And that reduces to 7 plus or minus root 37 all over 2. And that simplifies to this or this. 7 over 2 plus root 3 over 2, or 7 over 2 minus root 3 root 37 over 2. Sorry. So now when you get this, when B equals this, what will A be? All you have to do is to subtract what B is from 7 to get A, and simplify to get A. And that will simplify to this. 7 over 2 minus root 37 over 2. Then when B equals 7 over 2 minus root 37 over 2, your answer simplifies again. Your answer simplifies again to this. Okay? So that makes our square root of the square root of 7 minus 2 root 3 either this when this is A and this is B, or this when this is A and this is B. Now I would want you to try your hands again on these two problems and drop the comments you have or the challenges you experience while getting them done in the comment below. Please like our video, watch our videos thoroughly to understand what is actually being said, like our videos, share our videos, and most importantly, subscribe to our YouTube channel for more videos on Surds and other related topics or other topics in mathematics and statistics. And I'll see you in the next class. Thank you.